Now let us do some numericals related to conversion of galvanometer to ammeter and voltmeter. See, basically galvanometer is a device used to find the presence of current in a circuit, and it is having a very low resistance, almost equal to 12 ohms or 15 ohms, something like that. Now this galvanometer can be converted into an ammeter or voltmeter. An ammeter is a device which measures the current, and voltmeter is a device which measures the potential difference. So you have a question, a galvanometer of 12 ohms. So you have the galvanometer whose resistance is 12 ohms, shows full scale deflection, means the needle will reach the other end. So normally the needle is at the middle, the needle reaches the extreme end when a current of 3 milliampere flows through it. So that is normally taken as Ig, which is the maximum current or the current which is required for the needle to deflect to the extreme end. So Ig is given as 3 milliamperes, and the galvanometer's resistance is already given, and you have to convert it into a voltmeter. So you have to convert it into voltmeter to measure from 0 to 18 volt range. So it means the needle should reach the extreme end only when you apply a potential of 18 volt across it. Means the galvanometer must be able to read from 0 value to the 18 volt value. Hope you understood the logic. Normally if a current flows through it of 3 milliamperes flowing through it, and the resistance is 12 ohms, so 3 into the 0.36, or you can say 1236 milliamperes, so 0.036, right? This much volt is enough for the needle to reach the extreme end, and you are going to convert it so that the needle will reach the extreme end only when an 18 volt is being provided. So how to convert a galvanometer into a voltmeter? So galvanometer is having a very low resistance, and it can measure, as we did in this case, 0.036 volt. The needle reaches the extreme end, so you can connect a high resistance in series with the galvanometer, and this arrangement becomes that of a voltmeter. So galvanometer connected to a high resistance in series is what you mean by a voltmeter. Now how much, this becomes a voltmeter. So how much current is flowing through the galvanometer? That is Ig. And how much voltage it has to measure? It has to measure up to 18 volt, 0 volt to 18 volt. And we know the potential from this resistance to the end of the galvanometer is equal to Ig times the R value, plus, that is the resistance which you are going to connect in series, plus the galvanometer's resistance is equal to the maximum potential which I want to have, that is 18. So Ig is given as 3 milliamperes, 3 into 10 raised to minus 3 amperes. Resistance value, I don't know how much to connect to do this, so let it be R, and resistance of galvanometer is given, that is 12, equal to 18. Why 18? Because that is the maximum value which I want to measure using this particular voltmeter. So 0.3 times 10 raised to minus 3 times R equals 18 minus 12, 6. So R will be equal to 6 by 3 times 10 raised to minus 3. So 2 times 10 raised to 3, or 2 kilo ohms. So when you connect a 2 kilo ohm resistance in series with the galvanometer, then the galvanometer will be able to measure a voltage up to 18 volt. This is how we connect the galvanometer into voltmeter, by connecting a high resistance across it. Why did we connect a high resistance? Because the galvanometer's needle will reach the extreme end if you connect a very low voltage, so 0.036 volt, when you provide, the needle will be at the extreme end. But I should make the needle to reach the extreme end only when 18 volt passes through it. So I should provide a high resistance across it. So that is its value can be calculated like this, because drop across resistance plus drop across galvanometer is what I want to measure, the maximum value which I want to measure. So we will get the R value equals to 2 kilo ohms. Now the same logic, when you want to convert a galvanometer whose resistance is 15 ohms to a ammeter to measure from 0 to 6 amperes, and the galvanometer's needle reaches the extreme end when a current of 4 milliampere passes through it. So what is Ig? Ig is 4 milliampere. How much current do I want to measure? That is I, that is 6 ampere. So what is the logic? You connect a low resistance in parallel, you call it as a shunt resistance in parallel to the galvanometer, and this whole arrangement acts like an ammeter. What is the logic of connecting this small resistance in parallel? See, I want to measure up to 6 amperes. But if I am not connecting this resistance, means when a current of 4 milliampere passes through the galvanometer, then the needle will be at the extreme end. Then from 4 milliampere, whatever be the current, the needle will be always at the extreme end. But my needle should, the galvanometer's needle should reach the extreme end only when 6 ampere enters the circuit. So what should I do? When 6 ampere enters, then only the 4 milliampere should pass through it, and the rest should be bypassed away. So the rest should pass through the shunt resistance. Now if I am connecting a large value for shunt resistance, what is its use? It will be logical, because high resistance here means no current, very less current will pass on through it, maximum current will try to pass through the galvanometer, again it's of no use. So you have to connect a low resistance in parallel so that the maximum current passes through the bypass path. And if I want to measure 6 amperes and the galvanometer needle will reach the extreme end by 4 milliampere, so logic is that when 6 ampere enters, then only the 4 milliampere should enter the galvanometer. So how much is the shunt resistance which I have to connect in parallel? See, the voltage across these two ends will be same, because this and this are in parallel. So I can write Ig times, that is the current through the galvanometer, times resistance of the galvanometer, is equal to I is entering, so Ig is going into this, so I minus Ig will be passing through the shunt resistance. So I can write I minus Ig times S. S value is what I have to find out. So Ig is 4 milliampere, 4 into 10 raised to minus 3. Galvanometer's resistance is 15, equal to I is 6 amperes minus 4 into 10 raised to minus 3 multiplied by S. So S will be equal to 4 into 10 raised to minus 3 multiplied by 15 divided by 6 minus 4 into 10 raised to minus 3. So when you calculate, your value will be something near to 10 milliohms. So hope you understood the logic how the galvanometer is converted into voltmeter and also to ammeter. Whenever they say the voltage range up to this, means the maximum voltage is what they want to find out, is the final value, that is 0 to 18 means up to 18 they want to measure. Similarly, when the ammeter is to be converted into ammeters, they will say 0 to 6 amperes means 6 amperes should be taken as the I value, and the deflection current should be taken as the Ig value. And when you substitute using this logic, you can easily find out these values. Rather than by hearting those equations, just imagine what is actually happening. Then you will get a clear-cut idea how to solve complicated problems also.